Welcome back, friends. Thanks for being here. This is Steve, KM9G, and today we're going to build the JuiceSpot. This is a 1 in, 2 out on Anderson power poles and a 1 out on USB. So you can take your mobile station and get your Raspberry Pi powered from your Bioenno or other similar battery pack. This is going to be a tight build, and there's going to be some bloodshed and some tears. So stick around. Oh, and down below we've got the join, the like, the comment, the subscribe, the bell, the all, like all those 7,000 things that YouTube wants you to do. Even the dislike. I mean, don't, but it's there. It's not very tempting. It's not as nice as the like button because it goes down and the other one goes up, and we like things that go up. All right, cool. We will see you after the break. Okay, this is the JuiceSpot, and what this thing will do, if I can not drop stuff, is give you 2 power poles and a USB out, so 12, 12, and 5, and then a single power pole for input, and that makes it pretty easy to tell which side's the input. Although technically for power poles it really doesn't matter. I have this one here from PowerWorks, where it is any one of these is in and any 3 of these are out, but not any more than 1 are in, because that would be weird. So we're going to try and build this thing today, and I have an idea of how I want to make this happen, but I'm not 100% sure. What you're going to need is the JuiceSpot 3D STL file, which you can find on Thingiverse and in a description link below. And you're going to need some power pole connectors in the description below, and you're going to need a buck converter, B-U-C-K, I know what you were thinking, buck converter, and this is going to take 12 volts and drop it down to 5 volts. And this is the model that was designed to work with the JuiceSpot. So it will be held into place by a little channel in the bottom of the 3D printed case. Pull it back out again. A little channel in the bottom of the 3D printed case right there, and a little notch there that goes between the USB port and the buck converter itself, and so that will just slide nicely in there. And then there's another channel on the top side of the case as well, so that will keep that from moving and you won't need to secure that. And then there are some little tiny screws here. This whole thing was sent in by the Smokin' Ape, and there's a link to his channel down below and up above. And thank you very much, Ape. You get to watch me curse and swear as I build this tiny little thing. So first thing I'm going to do is get out some power pole connectors, and I'm going to try and get these guys set up and figure out measurements on the wires. And I always keep something power pole related nearby so I can get the orientation of the connectors correct, because you don't want to get those wrong, because we're dealing with some expensive equipment. So power poles have this little notch on them here that gets them connected. So there's 2, and there's 2, and there is 3, and I believe, yep, these will even hook together in this direction as well. So there's a 2-pack, and this is designed so that they get hooked in there and don't come out, and hopefully so that they get hooked in there and don't come out. Okay, so there's a little bit of a gap there, and then this is the positive side connector here and the negative side connector there. So positive to red and negative to ground to black. And right now I'm just trying to get an idea of measurements and spacing and such. And so that's what the finished project will look like. So 1 input, 2 outputs, and USB out. All right, and that's how you do that. It's all done. So measurements down below. No, I'm kidding. That would be the magic of video editing, but that would also kind of defeat the whole purpose. So I'm kind of wondering if I can just put bare wire in here, because there won't be anything in here that will touch anything. And then the only place I would use insulated wire would be from the buck converter, because that's the ground is going to pass through the positive. I might try that out. Let's see. Kind of strategize in here. Yeah, so that's not going to be big enough to put 2 in. I was thinking I might be able to put 2 in here and then just branch out. I may still be able to do that if I get smaller wire. This is 12 gauge wire, I think. Let me check. This is how I measure wires. I don't know how you guys do it, but this is how I do it. Yeah, so this is 14 gauge wire. This is already pretty small. Yeah, this is 14 gauge wire. Okay. Let me do some thinking on this. Might want to change wire, might not. Okay, so I rated the wire stash and I found some smaller wires, so now we got to do some math here because I need to figure out what gauge this is and then what kind of power rating it can handle. This is 100 foot of train wire made by Apex, and I found this in my my workshop that I used to do for model railroad stuff. 79 cents for 100 feet of wire. Fantastic stuff. Let's see if this is measurable on size. Yep, so it's 16 with the jacket. So it's even smaller without the jacket. And I'm going to say that's too small. Let's keep digging. Alright, a little bit more digging and I found some more wire. This is a little stiffer, but it doesn't seem like it's much bigger. Same thing, 16 with the jacket on. And this is 16 with the jacket on. This is 12 volt primary wire, which I only seem to have in black, which technically doesn't matter when it's inside, but would be nicer. Okay, so that's 16 inside the jacket. And this is braided. Let's get that nice and tight. Okay, so there is room in there for 2. Let's double check. Okay, that's the one. So they will both fit in there. That's perfect. Now I need to see if I have some red in this 12 gauge primary wire. And this 12 gauge primary wire is 16 inside the jacket. 16 AWG. So 16 looks like the magic number. And what I'm doing, just so you don't think I'm hiding stuff from you, is I got this great big bin full of electrical wiring stuff that I'm playing with. That looks promising right away. Yep. Found that one out. Perfect. Okay, so now we got to do some more interesting stuff here with wire lengths and whatnot. So I'm going to take this piece that I've already cut on black, and I'm going to use this as my sacrificial lamb here and get the right length on the wiring. Okay, just a hair shorter on that. Okay, so that's perfect for that. Get out my calipers. We'll put some measurements down below for everybody. Turn it on, put it in inches, and we are looking at, where's the 0 button? There's the 0 button. 0.28 inches, or 7.2 millimeters. To strip the wire back, okay. And then the next thing that we're going to have to do is get the length right, and that is going to go. You're supposed to be able to get these guys back out, so let's see if that's true. That goes in pretty far. Okay. Pretty close. Okay, so that is too long. Let's cut it again. I'm going to take off just that amount. Okay, I think that's the one right there. Let's get some measurements for you. Alright, so we got to strip back 7.2 millimeters. And then let's see how long this is. 32.5 millimeters. Well, I guess that's not the measurement that you need. 47.9 millimeters. Or 1.88 inches. Alright, so I'm going to make up a couple of them real fast. And by real fast, I mean as long as it takes me to make them. What we need now is 3 reds, 3 blacks to start. So hang on while I get them done. Okay, so now we've got all of those guys cut and twisted. And I got to retrieve the power pole connector out of the end of that. And I don't really know how, but we will find out. It's probably just as easy as I think it is. Okay, one size smaller on screwdriver. And yeah, I know they make a tool for this, I just don't have it. There's one. There's 2. Perfect. And then just for grins, I will bend that clip back up a little bit to try and restore it to some of its former glory. There's one. I don't remember which one it was. Maybe this one. Alright, perfect. So now I need a plan for how to get the buck converter connected, and I don't know yet. Put that there. Put that there. And this wire is too thick to make those turns. I basically have to make a U-turn out and come back and connect. And this is only 5 volts and not a whole lot of amps, so I probably don't need 16 gauge wire for that. Let's see what kind of wire I have. And you know what? I think we will try that train wire for this. Now, I only have a 16 gauge wire cutter, wire stripper, so we're going to try the Telco shears and see if they do the thing. And this one here, I don't know that I will need to measure it all that much. Are these shears going to work for this, first off? So Telco shears, if you are ever working in the phone industry, you would have probably seen these a lot. These are actually original, I don't know if you can tell by looking at the camera or not, Bell system, which is why I'm calling them Telco shears, because these came out of Ma Bell. And these were my dad's, at least. I don't know where he got them from, but he had a couple sets of them and he used them all the time, and these were always in his tool belt until they were in my toolbox. But there's these 2 little notches here on the back side of the shears, and those are designed for stripping wire. So you put the wire in, you hold it down, and you pull. And look at that. She's stripped. If we can get some contrast there. So that's all it is. And that, I'm not going to pull that out again, just to put it back in again. Fits nicely in there. That will be just fine. And it is flexible enough to make it around the corners, etc. So now what I need is an approximate length to get inside of the power pole connector. So let's start off long and work our way short and see what happens. So positive wire like that and like that. And what I'm going to do is I'm going to leave the end coming out of the power pole long, because I can always trim it after it comes out of the power pole, but I can't trim it on its way into the power pole. So same thing on the wire length to get you inside of the jacket, inside of the connector of the power pole. I'm going to put all 3 wires inside the connector, and then I'm going to come out the other end. So let's get some black wire and give it the same approximate length. Alright, I'm going to get that out of the way. I should have done that. Should have done that first. That got it. Okay, now let's get the soldering iron warmed up. Let's get the spade connectors all connected out. I need 6 of them. Okay. Because what I'm going to do is I'm going to crimp these and I'm going to solder them. And this is the iWis for Anderson power pole connector, it'll crimp 15, 30, and 45. And I don't remember off the top of my head which size these are, but if we put them in there, they look pretty happy on 45 and on 30. So I'm going to try these on 30 and we'll see what happens. Okay, soldering iron is warmed up. Let's do red, red, and red. And this is where it gets ultra fiddly, he says, not knowing what's coming next. Alright, I'm going to do this the other way. I'm going to put one in, and then I'm going to put two in. I'm going to kind of do them up and down like that. That way they line up better for what's coming up. Alright, that's a pretty tight fit. Will they fit in the 30s? Yeah, it'll fit in the 30. That 30 looks pretty good too. And there really isn't any room for me to put any solder in there. Where is my meter? I gotta find my multimeter. Oh, it's on the desk behind me. Good thing this is a small space. And I don't see any reason why this won't work, but I'm just testing out because I'd rather test it now than later. Perfect. I'm going to still try and get some solder in there because I don't want to take this thing apart, and I need something to keep it off of my mat because I don't want to melt my mat. Okay, and that actually takes solder pretty nicely. And it's hot. What a shock. Okay, now I just have to do that another 100 times. Okay, so next up is same side black. Beautiful. Love it. I guess just for completeness sake. Good. Oh, I gotta crimp it first. I heard you guys yelling at me. Perfect. Okay, now we got a black side done, we got a red side done, and why did I think there was need for 3 of those? Alright, red goes in, goes to those 2, goes to the buck converter, black goes in, goes to those 2, goes to the buck converter. Okay, we didn't need those after all. Perfect. I know, I'll use them as a prop in the opening of the video. That's what I'll do. You guys will never know, right? Alright, that's all set, so now we need to get connectors on the other ends of these guys. And what I'm going to do is be very aware of how they are sticking through. So first off, I want to make sure that I'm not doing something like this because it won't fit in the case. And second, I want to make sure I'm not doing something like that because I don't want to cross red and black and black. So when you put it in that way, that makes this spade connector go down and it makes this one go up. So as long as you got them in opposite orientations, you're pretty good. I mean, you can twist the wire, but it's easier to not have to even bother with that in the first place. So we got that. I'm going to crimp all these on, then I'm going to solder all of them on. So, and I'm wrong-handed for upside down orientation, I think. All right, there is that one. Perfect. And then same thing with that one. Perfect. Down, up, up. Okay. And we got those ones done, and we got those ones done. Perfect. And the only thing left to solder is the buck converter connection. And what I am going to do with that is I'm going to pull the buck converter out, and then I'm going to put all of these fine connectors in, and then we're going to cut the wire and see what happens. Alright, let's get these guys shoved into their final resting places. It sounds so final. And all I'm doing is taking my screwdriver and grabbing the back side of the connector and shoving it in until I hear a nice click. Perfect. Connector. And you can actually visually see if they've made it all the way or not also. Perfect. Perfect. All right, and that one goes in like that. Looking good. And that one goes in like that. Click. Oh, okay, here's a tip for you. Put all of these in all at the same time and then click them. Visual inspection. Oh man, it broke. I need to get me some more glue on that. Trying to be a little too heavy-handed there. So maybe a little tiny bit shorter on the wires than what I did. Let's get that out of the way and keep on moving on. Yeah, it's just a little too long. Okay, I don't have a whole lot of room to use these shears, so we're gonna have to do this the hard way, I guess. There's one, and there's two. In plus, in minus. And we'll do these one at a time. Snip off the extra. Okay. We put that in there, put that in there. Use something that's not as sharp to move that wire. Alright, all set there, all set there. Okay, so after fiddling with it and thinking about it for a bit, I think this is just going to break off again in the future because there's nothing holding it on in the top. And I don't know. I'll glue it in and we'll see what happens. That's what we'll do. What's the worst that can happen? But in the meantime, let's get those screws in there. These are Phillips head screws. And it looks like he's got a little bit of a recess in there for the screw head. It's not bad. I mean, it doesn't move any more or less than that one does. All right, so next thing up is to test it. I don't really have any way of testing the, I don't have a real good way of testing the buck converter. All right, let's get some power pole wiring up here. Hang on. Okay, so this is plugged into my benchtop power supply. And what we need is voltage. And let's put black on black and red on red. We got 13.62 volts. So let's marry up some inputs and some outputs here. Let the smoke out. All right, what do we have? Red and red, 13.62. Red and red, black and black, 13.62. And there's a little blue light coming off of the buck converter. Yeah, maybe you can see that a little bit in there. Okay, so let's try something USB powered. 1 second, I think I found something. Okay, something that I'm not going to cry too much if it doesn't work is these LEDs. Let's plug that in, and they work, and you can't really see it on camera. Ooh, look at that. All right, I'm going to consider that a win, except for this little broken piece here. We're going to glue that back in place, and sometime in the future I will comment back if it breaks again, and if it doesn't break again, then there won't be any future comment. That's the end of this build. Alright, I pushed some buttons, I said some words, I did some things, I got some solder, I got some glue. It's currently gluing up where I'd show you what the finished product looks like. But you can see in the video that we got it all up and running, and that was pretty awesome. I like awesome things. I'm going to put my measurements down below in the description, and I would suggest that you shrink them just a tad bit. And maybe that one post that comes out that I broke off, if you have the skills to edit the STLs, I would make that a little bit longer so that it had more strength, more shear strength, if you will. Yeah, I guess that is shear strength. I didn't take physics, so I'm just kind of like going with that one. Yeah, I'm going to go with that one. All right, cool. So check out right after this part here, I'm going to put up a bunch of people that sponsor this channel and make all of this wonderful stuff possible, and also help support getting youth on the air. If you would like to be a channel supporter, there is a join button below. There is a Patreon link in the description, and there's always super chats during premieres and whatnot, and they all help out a lot. So Thanks for being awesome.